Hey everyone, in this video we are going to talk about errors and error handling in C++. So these slides are linked from the webpage, and I'm going to try to remember to do 2 shorter videos because I've been having trouble with the recording software, and so maybe it'll be happier with a shorter video. So there are a lot of slides here, and I'm really just going to focus on how we can handle errors in our program. We talked a little about errors earlier in the class, and probably whether it's in your class or previously in your programming career, you have found that discovering and fixing your own errors is a huge part of programming. But really what we're going to do is we're going to think about how we report our errors to the user. So the main way that we're going to do that is by throwing an exception. So we'll actually see 2 different ways to do this. I guess to start off, actually, we have some examples. So I think, okay, I'm going to try to copy everything over from public examples C++. So you have access to these as well. And I'm just going to try to copy everything and see if that works. Okay, that looks like it did. So to start off, let's look at vecerr.cpp. And so in this program here, we are declaring a vector v, and we can actually fix the size of a vector with this syntax. So before our vectors, we did not have anything like that, but if we include this, now we've said that it has a max size of 10. And so here we see that we're filling our vector with ints 0 to 9. So it's going to go 0 to 1 minus v.size, so 0 to 9, and we just set v at I to I. But then in this for loop, we're going to print the vector at I up to, and this is kind of the key here, we go all the way up to index 10. But our vector doesn't have an index 10. And so we'll see that C++ is actually going to allow us to do this, and we're going to get behavior that we wouldn't really want our program to do. Here we are also printing the elements of v using a range for loop. So we saw this in a previous video, but we have our type int, and then we're gonna use the variable name Ella or something like that, ELE, for everything in v. And so this one we're not gonna, it's only size 10, so it's only gonna print those 10 elements. But let's just go ahead and see what happens here. So we'll compile. We'll call it vecerr, and then let's see what happens. So in that first for loop, we do print out this v sub 10, and there is an integer there, so we print it, but we really don't want that behavior to be allowed. And so one thing we could do potentially is, so these when we use the brackets, C++ does not have built-in bounds checking when we use the brackets. But if we use the at method, there is bounds checking. And so if I make this one quick change and I compile and run, you can see that we actually, the program quits because we got a out of range error. And that's because the at method actually does some bounds checking. And so the first thing I actually want to take a look at is how we can handle errors that are coming from built-in C++ constructs. So things like this. So the way that we can handle this is with try catch. And so what we do there is we can put the code that we think might throw an exception inside our try block. And so this is where we think that might happen. And then what we then need to do, so now I've put the code that might have an error in it inside my try, and now I can catch, and I need to specify what I'm going to catch, and then I can also specify the behavior if I do catch that exception. So in here I need to put actually a data type, so what is the thing I'm going to catch, and in this case we actually saw it. Let's see. Oh, let's write this so we can see that what was printed at the screen. So we saw that it was an instance of out of range. So we're using the standard namespace, so we're not going to need this std : here we go. So I need to put in that data type, and it turns out that, so this was out of range, but I also actually need to, in this case, if I'm catching a built-in exception like this, I'm going to need to follow with the ampersand. When we catch our own user-defined errors, we won't need to do that. But then I would like to write to see error, and maybe I say something like error out of, I'll say index out of range. And then I'd like to put a new line there. And then I also want to end my program. And so I can do that by returning 1, and now the operating system knows that something bad happened. When I return 0, that's when the operating system knows that everything went well. I return something else, then the operating system knows that something bad happened. So let's try this out. And indeed, here we see that we get that message, just like we wrote it up. So another example of this, in word error, we already have in that example folder, the C++ error examples, we have a really similar program, and we see that we are creating a vector of strings, and it's called words, and we're saying that it should have size 5, but then we're asking the user to enter strings as long as they want, and we're putting them in, and so we can overflow this vector. So let's see what happens. Let's look at wordsin.txt. So this is a file that has clearly more than 5 words. So let's compile and run this and see what happens. We'll call it word error. And let's run it. Oh, we need to use redirection to input that file. It's wordsin.txt. And so here we're just getting a totally unhelpful message, right? It's very hard to interpret as a programmer if I'm trying to figure out what's going on, or certainly as a user, this would be very bad behavior. So let me, again, we might use the @ method, so at least we're going to have a more descriptive error when we go out of bounds, so let's try that. And I think we should get, so yeah, now we get another out of range error, and I believe word error 1 shows an example of putting in that try catch that we saw in the other example too. But let's try. So now we're going to look at word error 1, and we see that, oh, again, gotta actually put in my words in. And now we're getting this nice behavior that the vector index is out of range, versus what we had before. Even when we were catching it, or no, even though we were actually throwing sort of a more descriptive, giving some more descriptive information, here we have a nice graceful termination of our program. So that's how we can deal with errors that are automatically generated by C++, but we might also want to generate our own errors. Maybe we want, based on the input that the user gives us, in certain cases, we want to just terminate the program and say that was a bad input. So building off of the try-catch statements that we've seen, let's take a look at, let's see what these are. I believe it's errors 1. Yeah. So errors 1 is a program that is doing what we see on the slide. So we said earlier that our catch, the input, what we need to put in here is a data type. And so if we want to define our own errors, we need to define that data type. And we can do that by defining our own class, and we'll say it's an empty class, for our error. So the syntax here, we can just say class, and then the name, for readability's sake, let's make that a nice descriptive name, and then we just have our curly braces with nothing in them. So this is just an empty class. And now, if we do throw something of this type, then we can define behavior that should happen. So we can write to see error, we can say oops, bad inputs to area calculation, and again we'll return 1 to end the program. And so let's see, where might we actually throw a bad error, a bad area error? It's in this area function that takes in length and width, and if the length is less than or equal to 0, or the width is less than or equal to 0, that's when we're going to throw that bad area. And I just realized I forgot to make this into 2 small videos, so I'm hoping that this video works. So we have our bad area defined. So let's see what happens here. Actually, let's see what happens if we don't trigger that throw bad area on line 9. So we have actually some good inputs here. And let's compile. And run. It's errors 1. So that went well, but now let's change this so that it is no longer a good input. It's negative. So up here, we should go into this if statement. So let's see what happens. And indeed we did. So one example that could be useful is, what if we had actually another input, another type of input that we want to terminate the program for. So let's say maybe we're going to call it big area. So maybe for some reason we don't want, if the area is too big, our program should end. So we're going to have to define this big area class, but what should we do if we do throw this? Let's say we, again, print some information. We say, again, oops, and we'll say big area. And let's return 1 again. So we have not defined it yet, but it is easy to do that. We'll say big area. We just make an empty class. And I need a semicolon. And then now let's say, when should we do this? We should do it if length times the width is, let's say, greater than 100,000. 100,000. And so then we should throw our big area. And now let's actually make it so we do that. So let's say this was 100,000. And now we're going to need to recompile and run. And we're seeing that that's working. So this is a good way to do Lab 5. I will stop the video here, and we'll see in another short video another way that we can terminate our programs.